We're going to do some practice with maximizing area and minimizing perimeter. An elementary school would like to fence in the kindergarten play structure. The fence is expensive, so they want to minimize the perimeter by using a side of the school. The school is required to have an area of 250 meters squared fenced off. Generally, there's a requirement that you need a certain amount of space for each student, so it's probably based on that. What is the minimum length of fence? Okay, so the first thing we should do is draw a picture and figure out the important parts of the question. So here is the wall of the school. And let's add the fence. Okay, and let's just highlight some of the important terminology here. So we're trying to minimize the perimeter. That's important. And we have 250 here. 250 is the area, 250 meters squared. And we're being asked, what is the minimum length of the fence? Length of the fence. Length is a perimeter. So we're trying to get minimum perimeter for an area of 250 meters squared. So we made a diagram. We should label the diagram as well. So generally we have length, width, we have another length. The wall side of this rectangle, well, that's free. We don't have to put a fence up against it. So that's nice. We just have two lengths and a width. So we're trying to find an area of 250 meters. We can write an equation for this. Area is equal to length times width. We know the area is 250. So the length times the width has to equal 250. So that's one piece of information that we have. It's important. Let's put a box around it. Now we're also dealing with perimeter in this question, so it's pretty reasonable to write an equation for the perimeter. It might be useful. So perimeter. Now we don't need that wall. It's not really part of the perimeter. We just need a length plus a width plus a length. So we have two lengths and one width. So this is an expression for the perimeter. What's the value for the perimeter? Well, we don't really know that yet. We're trying to figure that out. There's a few different ways we can do this. We could just figure out some different choices, do a guess and check strategy until we find the best one. So let's start with that. So let's guess a length and figure out a width. If we're going to do that, we'll need an equation. If we're going to guess the length and figure out the width, then we'd want to have the width all by itself in this area equation. You'll see why in a minute. So to get the width by itself, we would divide by the length to isolate the width. So the width is equal to 250 over L. And over here, the length cancels, so the W is by itself. Okay. So we're going to guess the length, figure out the width. All right, let's make a little table of values so we can keep track of everything. So if we did a length, let's say, of 10, what would the width be? The width would be 250 divided by 10. $25. Okay, well, let's figure out the perimeter. So we have, for the perimeter, 2 times the length plus the width. So 2 times the length plus the width. And that is equal to 20 plus 25, 45. Okay, what are some other lengths that we can try? We could try a length of 15. Now we have 250 over 15. I'm going to use a calculator to make sure I get the number right. I could reduce the fraction pretty easily, but if we want a decimal, this is a little bit trickier. 16.6 continuing. If you wanted to round it, you could do 0.67. And now for the perimeter, it's 2 times the length, which is 15, plus 16.6 continuing. Okay, so I kept that 16 continuing in my calculator, which is really nice because it's very accurate, and I'd end up with 46.67. Okay, so already we can have a look at our numbers, and what's better, the 45 or the 46 for the perimeter? Well, we're trying to minimize perimeter, so we want the smallest perimeter. So right now 45 is better. So it looks like as our length is getting bigger, the numbers are not as good. So we could try something in between 10 and 15. So I called this method sort of guess and check. So notice how we had to look over our answers and think about it. Okay, we get another number that's not too beautiful. And the 3's go on and on and on. 2 times 12 plus 20 continuing. So we have 44.83. Okay, so what do we notice about our numbers now? Oops. So we had 45 when the length is 10. We had 46 when the length was 15. 12, we have a lower perimeter than we had at 10. So we want to maybe check 11 and check 13 and see which one works out better. So let's try 11. So in this case, I have a repeating decimal with 72's repeating, so I put the line over 72. And you know, all of these I actually rounded, so there should be a dot over top if you've rounded. And I'm just going to round that to 0.73. Okay, so what was better? 12 or 11? 11 was better. 10 is worse. So we're starting to see a bit of a pattern here. It's kind of tricky. We could try lengths of maybe 11 and a half. We could continue getting fractions till we get nicer and nicer numbers, but the answer's somewhere in between here. When it's hard to get a whole number solution, it can be helpful to graph something. So if we this on a graph. I prepared a graph here, but notice I have perimeters that are around 40. My scale's not very good on this, so I'm going to come back to this graph. This is in GeoGebra, and I'm going to change the scale. I don't always get this the first try. Okay, I was trying to grab it and drag it, but that's not working, so I can do it here. So we want to be able to see those 40s. Let's do 40 to 50. And let's do length on the other set of axes, on the x-axis. And we were trying things between like 10 and 15. So 10, 15. I didn't think this through. They're not going to show me the axes like I want them to, so. Okay, so I could just use this graphing program and I could plot all the points. I could use GeoGebra and plot the points, and I could go back and forth and see the points here. But instead, I'm going to pull the graph into Paint and do it manually. You're often going to do things manually, so it's good to see it being done. Okay. So let's plot the length on the x-axis, the horizontal axis, and the perimeter on the vertical axis. Okay, so a length of 10 has a perimeter of 45. So length of 10, perimeter of 45. A length of 12 has a perimeter of 44.73. Okay, so notice how in this graph, because of the settings for the horizontal and vertical axes, these points are all very close together. Okay, 12 is 44.83. It's very difficult to see any pattern whatsoever. So it would be a better choice to use line breaks. So I'm going to go back here and reset the grid. this is better because we can set up the numbers the way we want to. Get our scale more appropriate. Okay, so I'll do a little line break. Our values are mostly 10 to 15, so 10, 11, 12, 13, 14, 15. Now for our perimeter, we'll do a line break as well. And our values are mostly between 44 and 47. So we could do like, I like to think about it before I actually put the numbers in, 44, 45, 46, 47. That only used about half the graph. So instead let's go up by half. So 44, 44 and a half, 45, 45 and a half, 46, 46 and a half, 47. Okay, now let's plot the points and see if we can see a bit more of a pattern. So at 10 we had 45. At 11 we had 44.73. So that'd be just below 45. There we go. At 12, 44.83, slightly higher. 13 we didn't do, 14 we didn't do, 15 was 46.67. So slightly above right there. Okay, so there's a bit of a pattern here, and if you weren't quite sure about the pattern, oh, I made a mistake. I put that point at 14, we want to put it at 15. If you weren't very sure about the pattern, you could try doing the values for 13, the values for 14, a value for 9, but it's basically a curve. And I can see it goes something like this. And the bottom of the dip here, it's probably the lowest right around here. Maybe around about 11 and a half. Okay, so we're trying to figure out the minimum perimeter and it's somewhere around here. So it's approximately a length of 11 and a half, and we could figure out the width. So if the length is equal to 11.5, the width is 250 divided by 11.5, which is equal to about 21.7. Okay. And it was really close also. This one here, the 11 and the 22, 23 was pretty close, and this one's pretty close. So to answer this question, what is the minimum length of fence? So the length of the whole fence is length and width and length. So 11.5 and 11.5 and 21.7. So therefore, do we want our answer to be in meters or in meters squared? So we're doing perimeter, we're doing length, so it'll be in meters. Therefore, the length of fence is about 44.7 meters. Okay? So that was a pretty tricky question. If they asked you to have the length and the width to the nearest meter, then you would look for maybe 11 would be the best choice because it's fairly close to 11. Now in general, there is a pattern here. So look at these numbers that were very close. 11 was very close, and we had 11 and 22.7. 12 was pretty close, and it was 12 and about 21. Our answer was 11 and a half and about 22. Do you notice a pattern here between the length and the width? It looks like, in general, the width is twice as long as the length. And that will minimize the perimeter. So that's true. To minimize the perimeter, you want the width to be twice as much as the length. So the side, when you're making a rectangular shape where there's just 3 sides, the side that doesn't have a parallel side, you want that side to be twice as long as the other sides.